Okay, students. So now today we will see the logistic regression problem with simple way. The regression is not a simple topic. Regression is not a easy topic. Sometimes we will think regression is very big topic in which how we can manage a thing. Nothing. A regression is a mathematical model in which we have a various flavor. Those are the linear regression where we have to use the equations line that is a y equal to mx plus c, that is straight line equations. So this straight line equation can have the many, so we have the multiple linear regression. So when we have the multiple straight line in our model, that's why we have the multiple linear regression. But in the case of the polynomial regression, as I got the message from the other students, so I can speak over here in summarized way. When we deal with the linear data, it means when talking about the data that can represent the information in a linear way, that at the time we have a linear model, and the linear model we have the two type. One is a linear regression model and other one is a multiple linear regression. In the non-linear based model, what is the non-linear based model? Yes, of course, the when we don't have the line in the straight line way, it means we are talking about the non-linear data. So when we have any data set which is not represented by the non-linear way, at that time we have a data which is known as the non-linear way. And in this case, what is the problem we have? We have a problem that is known as the polynomial regression. In the polynomial regression, what we have to do? We have to take the one independent variable, one dependent variable, but the particular dependent variable can have the many degrees. So poly means many, nominal means degree. Actually, this is a Greek word. I'm speaking very frankly speaking right now, but I'm not moving to the mathematical part, but I'm just giving the some message to all the students. Polynomial word is coming from the Greek word, which means to define that many degrees. So when a regression which can have the many degrees, so in which we can represent our information into the non-linear way, and that is a representation of our information. So why polynomial regression is more successful? Because it will touch or it will be close to the all the data point. And we finding that we have seen over here in the regression, the data set which are not close to the data, the plotted data are not close to the line. So we have the big margin of the gap. But in the polynomial regression, what is the beauty of what is the advantage? We have the gap of the actual data points, target data points are close to the target data point or close to the regression line. So that's why we can say we have a minimum gap. So the polynomial regression is more important, or we can say the most successful rather than the linear and multiple linear regression. So this was the introduction part of the regression we have seen. But what we have been observed, in this case, we have used only the continuous data manner. But in the logical regression, when we are using the classification based data or categorical data, then we have the logical regression. So logical regression, I will keep the in simple way, and thereafter I will tell you the introductory part of the practical parts of the logical regression. So our lecture will be divided into two parts. One is the introduction of the logical regression, and next we have the practical part of the logical regression. So first, let me complete this part, that is the logical regression by the theoretical way. So let me move to the next part. In the next slide, that covering the regression. So as I told you verbally, what is the regression, and we have already discussed regression many times. But logical regression analyze predict the outcomes in a binary variable which has only two possible outcomes. Why binary? Because either we have the two options, yes, no, true, false, 0, 1. So that's why we have the binary variable. It means two type of the information we can manage only. That is the beauty of the logical regression. So when we have the data in two ways or two classification way, so we have the binary classification. That is the point we have to understand. That is undercommon to the type of the logical regression we will see. So I'm just taking simple example, a real life example. As a student group, we have the two type of the student group based on the gender features. So a student could be the male, student could be the female. So what I'm doing the classify my data based on the gender feature. So that is very applicable data, and that data is not under into the classification data, or we can say the categorical data. So this is just our idea from which we have to start the logistic regression. Now let us understand what is mean by the logistic regression. Logistic regression, as I told you, it is a classification problem. It is used to represent the data into the categorical manner, and logistic regression is more important when we have to categorize the data into the classification way. So when we have the data into two type or two form, then we can say this is a binary classification. But there is no guarantee every time data will be classified into the two way or two form. There are many chances when the data can be classified into the many form. Yes, of course, it's possible. Like the example, in a group of the student, I need to choose the students who belong to the cyber security, who and other belong to the cyber and BI, or we can say AI and ML specialization, and other belong to the core computer science. So what I'm making the group of the three different kind of the form. So at the time, this is known as the binary. This is known as our multinomial classification. Means multi form of the our classify the data, and that is under coming to the once again the another type of the logistic regression. So remember that the classification task have discrete categories unlike the regression task. So from this perspective, from this point, we have to start the logistic regression. So I have spoken few idea about the what is the logistic regression. It is clear to all right now? Just tell me right now, is it clear? The fundamental study is clear?
Yes,
Yes, sir.
Yeah, good, super. Now, next we have the difference between the linear regression and logistic regression. I have taken this image in simple way to all the people so you can easily understand. So, in the linear regression, what you are observing? You are observing in the linear regression, we have to categorize the data. We have the data into the one manner that is known as the straight line equation. So I'm just removing the unnecessary point over here, then the thing will be more clear to all. Now see, in the linear regression, the line will be used to represent your data. So that line will be identified by the straight line equation or straight line. So we can say this can be identified by the y equal to mx plus c. I can write over here y equal to mx plus c. This is the line equation I am taking over here. So if y value becomes the 1, if y value becomes the 0, so the range we have the 0 to 1 only. So this is the line which is known as regression line. So prediction will be ranges from the 0 and 1. So we can predict our information from 0 to 1 only. So that is the point. But how we can predict y equal to mx plus c equation? But this line linear regression is just suitable only for the continuous data manner only. But when we have the categorical data, how we can use? So the prediction analysis algorithm will be use the probability concept. So when we have the ranges of the data from 0 to 1, so we have to say we have the 0 and 1. It means that if information contained in our part, so it will be represented by the only some probability. So if I belong to this class, then my probability chance will be like this one. If I'm having this probability, so I will be of this class. I'm taking a simple example. Suppose you are getting the 80%, then you will get the S grade. But you are getting the 84%, so this is what? This is known as you are coming into the A plus category. So you are losing one grade by losing the 1 marks only. So this is what 85 is the value that defines the benchmark, that defines the your entering part from which you can easily understand what is the point. So this is a benchmark is also known as that is our threshold value. So what is the threshold value to enter inside the our to get the our upper grade or to get the lower grade? So in the logic regression, what we can assume this midpoint. So I can draw this one. This midpoint could be that is 0.5. I can say this midpoint will be our threshold value, or this is known as a benchmark. So if I am getting the value which is lesser than 0.5, so this value will be considered into the 0. So you can see all the data points are plotted or depicted at the y equal to 0 line, because the outcomes of the y we are getting which is lesser than 0.5. If you are getting the if you are getting the value of the y 0.5 or more than 0.5, so the value which are depicted by this point. So the prediction that will be lies between the 0 and 1 only. So in this case, what we have the very important point. So you people are required to understand what is the important point by which we can easily say yes, yeah, we are getting the thing properly. So you can easily check over here. Either you will get the 1 or 0. So the line which is drawing inside the logic regression, that will be shaped into the as manner. This is the line I'm just depicting or drawing in front of you. So this is a line which is depicted by the S. This is the S shaped line we have. So we can say this is known as our ash shaped. I can write over here the line or the curve which is depicted by in form the as shaped. So in the logical regression, always your information will be depicted by the as shaped pattern. This is the regression line, we can say, that is depicted by in form of the S shape. What in this case, what we have the straight line followed by the equation y equal to mx plus c. So what is the S shaped and why we are getting this thing? So there is a function which is known as the logistic function. So this logistic function determines the cost of our logistic regression model. So logistic regression is a machine learning algorithm which is used to classification problem, and that is used to predict the analyze the algorithm based on the probability. So if you are getting the probability more than the 0.5, then you will get the outcome 1, else your probability will be less than 0.5, then you will have the 0. But as a mathematical rules, if you are getting the values on the boundary 0.5, so it will be considered as a 1. Now, this is a clear to all right now. This basic difference is clear to all right now. Difference between the linear regression and logistic regression. Is it clear? Yes, tell me right now. Is it clear? The basic difference is clear.
Sir, what is
Yes,
0.5? Is it p-value?
This is our threshold value. 0.5, we can say we are assuming over here, this is our threshold value. So I am assuming this mid value. So this value is known as threshold value. This value is known as the threshold value. We can assume any value. Suppose we want to assume the value 0.7. So the value which are less than 0.7, it could be 0.6 or 0.5. So that will be come into the y equal to 0. So all the data points will be depicted on the such a line, as it will be depicted on the y equal to 1. So the value which are lesser than, I will tell him with the help of one example, so that everything will be clear. But I'm talking about right now this logistic regression diagram is clear right now. Tell me.
Yes, sir.
Okay, so this is a point we can understand. So we have to understand the logic regression based on the predictive analysis algorithm, and it requires the internal mathematics, that is the probability. So we will not touch the hard mathematics. We will see on the basic mathematics as we have studied into our 9th, 10th, 11th, and 12th standards. So this is the point. Here we have to understand some basic theory portion. So I'm just giving some idea over here. So logical regression is a technique to analyze a data set which has a dependent variable. So it is having the regression. So it will keep the term dependent variable, independent variable. So it can have the more than one independent variable is also possible, and to predict our outcome. These independent variables is known as a predictor variable, or this is known as the features. And we're talking about the dependent variable. Dependent variable also known as the target variables, as we have seen in the regression part. So this is just basic terms from which we have to understand. If you're talking about the regression, I'm saying regression. So regression means we're talking about the dependent variable and dependent variable. And this is also recognized by the target variable or predictive variable, or it is also known as a feature variables. So logistic regression will use a logic function implicitly to determine our value, and this logic function is known as the logistic function, and this logic function is also known as the sigmoid function. So I'm coming on that part, but before that, you have any doubts, so you can ask. Now, just tell me right now. This idea is clear. So far, idea is clear. What is the logistic regression? Is it clear?
Yes, sir.
Okay. Now, so let us move to the some little bit more theory portion, and it is required to understand the basic idea. Logistic regression is a special case of the linear regression. Now, how? This is the very interesting statement which is highlighted over here. Logic regression is a special case of linear regression. So how? Of course, it is a case of the linear regression, but in the linear regression, what is the line we have? We have the line y equal to mx plus c. So by which our we are following the linear regression. So rather than the y equal to mx plus c, if we are using the log function and that is used to the logit function, I have already written over here and I have marked by the circle way. So if we are using the logit function to determine the outcomes of the our target variable, so that ranges from the 0 and 1 only, or it finds the classified of the data. So we have the logic regression. So in the linear regression, what we are using the continuous manner of data, but that is defining the value in a specified ranges, in a specified manner, but that support the cost function, that support the function followed by the straight line equation, that is y equal to mx plus c. But in this case, we have to use a function that is known as a log function. And we will not define the log function, we will not use anything in our code, just whatever we are getting, it defines the log function automatically. So log function is our logic function which is used to interpret the value, which is used to predict the outcomes either by the 0 or 1, true or false, or yes or no. And we have to use a function that is known as the logistic function, and that function is known as the sigmoid function, by which our regression line will be depicted in form of the S shaped. So that is known as the sigmoid curve, or that is known as the sigmoid function. And the thing we have the category threshold. So this threshold value or benchmark value will decide if you are moving this, if you're choosing this value, then you have come to the this, you have to choose this value, else you have to choose this value, and that is known as the win or loss. So there will be two probabilities. If you are playing the cricket, there will be two probability, either you can win or either you can lose. Okay, tie is another case, but if you have to keep in mind, so I have to win the game. So what is the probability? You have to eager to win the game. So this is your probability for the winning the game. And while watching the cricket over the internet or from the television, by which you are just watching the cricket, so you have seen the some probability or percentage you are getting. If India is playing the cricket, so 97% chance to India can win the game, or 3% chance India can lose the game, because India has a high score in this match. So there is some probability. But opponent teams are playing very fastly and very well mannered. So we can say now this ratio has been changed, and this is changing by dynamically. This is a real example I am taking. So we have the two options, that is a win or loss. So based on the probability, definitely we can say what is the your category, what is your chance. So here you can choose the yes or no, you can choose a 0, 1, or you can choose a win or loss, or you can choose a true or false. So these are the things which are coming to the threshold values. I can take the threshold value example by a simple example. Before that, I can insert one more important point over here for a betterment. Yes, I'm taking a simple example, so the picture will be more clear. Let me take in one example, very interesting example, so the thing is really clear. So here I'm just putting the data of the student of the height. Okay, I'm just giving the height. I'm taking the example of the threshold, so the idea, the thing will be clear. And I'm giving the its value or value of the category. Value of the category. So I'm giving the random data over here of the height, just 172 inch, one Okay, 176 I can take over here. 150, 156, 162, 169, 140, and 155. So what you are observing over here, you have some data, and how you have to categorize the data in 0, 1 form only. So what I'm doing, you can put the 0 or you can put the 1 only. You can either put the 1 or you can put the 0 only. So you have to decide, tell me right now which value I can take as a threshold. Can you anyone tell me right now which value I must take as a threshold value? Just from this random data, tell me any value.
162.
Okay, this is a 162. Suppose this is a 162 your threshold value. So the value which is greater than or less than, so we will decide if value is greater than, then we will say 1, or if it is less than, then we'll say 0. And if value is 162, so we will also consider this would be as a 1. So this 172 is bigger than the 160, so we can put this the 1. This is the 1. This would be 0. This would be 0. And this would be 1. This would be 1. Again, this would be 0. And this would be 0. So this is what you are categorizing the data in two forms. That is a binary classification I am doing. It means two forms. Or instead of the 1 or 0, you can put the true false, you can put the yes or no, or you can put the 1 win or loss. So whatever you want to write. So this 162 is what? This 162 is threshold value. Just like this example I can take over here. Suppose this is the graph on which we have some data. Okay, and here we have some data. So first what you will do, first you will sort all the data, and definitely what you will observe, some data points which are coming. Just I'm taking only random data only for here, and some data I'm just example purpose I'm taking here only. So you can say the data, the information which are more than 162 or 62, they're coming into the one part. So this will be considered as a 1. This will be considered as a 0. So based on this data fact, you can say your outcomes will be treated as like a S shape, and this is coming through the our logic function or sigmoid function, and that's why we're getting the as shaped curve, and that is also known as our regression line in the logical regression, and this is coming from the sigmoid function, or this curve is known as the sigmoid curve. This value is coming from the sigmoid curve. And very truly speaking, sigmoid curve is more applicable, sigmoid function is more applicable while discussing in the neural network. Okay, so do not forget this function. And rest of the other details about what is the sigmoid function, how we can interpret such values, I will tell you with the help of the practical and theory part separately in the neural network. But introduction part is required to over here, so I have explained. So is it clear to all right now?
Yes, sir.
And that is the point we have to keep in mind properly. So based on our threshold value, we have to chosen this value. So this is the point. So we can call the logic regression as a linear regression model, but the logic regression use a more complex cost function. The cost function can be defined as a sigmoid function, and that is also known as the logistic function instead of the linear function. So how we can represent the linear function, the linear regression? Our straight line equation, y equal to mx plus c. So this is the threshold value I can say over here, and I told you many times. The hypothesis of the logistic regression, we can tend to limit to the cost function between the 0 and 1, as we have seen few seconds ago. And this linear function fails to represent it, as it can have a values greater than 1 or less than 0, and which is not possible as per the hypothesis of the logic. So this h0x is what, this is the hypothetical value. If it is less than or equal to 0, so it is coming into the 0 part. If it is greater than 0, so we can say it is coming inside the 1. So this is the our threshold value, and this threshold value we can represent by the mathematically hypothesis. But in our numerical portion, in the our practical part, we will not use all these things. We will get all the things automatically with the help of the function. So no need to worry about the hard mathematics over here. Just keep in mind the basic study of basic fundamental step, and that is more important. So what is the sigmoid function? Just this could be more interesting point. So far we have already discussed. So I am speaking to some statement over here. In order to map the predicted values to the probabilities, we use the sigmoid function, and the function maps any real values into another values that lies between the 0 and 1, as I told you, and as I shown over here through the diagram. And in the machine learning, we use sigmoid to map the prediction to the probabilities. And the sigmoid function or logistic function is a function that resembles an S-shaped curve when plotted on a graph, and it takes values between the 0 and 1 and squeezes them towards the margin at the bottom and top, labeling 0 and 1. Whatever we have seen so far, this is summary of the our part. So this is just idea about the sigmoid function, and with the help of the diagram, I will tell you each and everything. But is it clear to you right now what is sigmoid function and how we can depict the sigmoid function?
Yes, sir.
So this sigmoid function will be more applicable inside the neural network, because at that time we will see the sigmoid function detailed manner. Here I'm just giving the idea, and that is used inside the logistic function as well. Because logistic function sometimes also known as a sigmoid function. That's why I'm speaking over here. Because it will provide the two type of the data, 0 or 1, yes or no, true, false. So definitely we can categorize our data. So what is the sigmoid functions formula? That is very interesting. So in our linear regression, we have used a y equal to x plus c. But here what I'm using y equal to 1 upon 1 plus e to the power minus x. And what is x? X is a independent variable, that is a feature. And y is what? Y is our dependent variable. So what is the formula? Y equal to 1 upon 1 plus e to the power minus x. So if I'm putting the any x value, and based on this formula, if I'm getting the values, that value should lies between the 0 and 1 only. If you're getting the values more than 0 and more than 1, it means you are doing the wrong calculation. So what is the value variable? E will contain some information. So E values would be the 2.71828. So this is the most important values. This is exponential values we have to keep in mind. E will be represented by the 2.71. So I can speak this equation y equal to 1 upon 1 plus 2.71282 to the power minus x. Whatever the x you want to put, you can put. So this would be the equation, this would be the formula of the sigmoid function. Now clear right now? Just tell me right now, is it clear?
Yes, sir.
See, this is just equations we have to keep in mind in the neural network. We will not use this equation while implementing the logistic regression. We will use the directly method or the class properly, so everything will be fine. But while solving the numerical based problem and while solving the all the thing, this function will be applicable. So this function we will not touch in detailed manner. We will touch this topic or this sigmoid function equation in the neural network. So this is the equation we have to keep in mind. Why? Because we are understanding the logistic function. And logistic function is sometimes also known as the logistic sigmoid function. So what is the equation of the sigmoid function by which the our curve or the line will be represented by the S shape? That is the point. A student asked me a question, sir, if we have the multiple independent features, then how we can represent our equations? So at that time I told to him, the equations can be modified by equal to 1 upon 1 plus e to the power minus b1 x1 plus b2 x2 and so on. So b1 xn, because we're talking about the multiple independent variable. Here we have the one independent variables, and we have the equations by equal to 1 upon 1 plus e to the power minus x. So this is the equations we have to keep in mind. So I am not taking the hard mathematics, I am taking the simplified mathematics to justify the our concept only, nothing else. So this is the fundamental stuff you have to keep in mind. So is it clear to all right now? And I am pretty sure, I am 100% sure, having seen this equation in the neural network, then you will be happy. Oh, sir, at least we have know these equations. So that's why I'm speaking over here. Just keep in mind these equations only. Now, is it clear to all right now? Is it clear? Please tell me right now. Is it clear?
Yes, sir.
Okay. Now, are you able to see this diagram, which is visible over the screen? It is clear to all right now.
Yes, sir.
Okay. So what this diagram is telling to us. Now you can see how this is the two graphs we have. One graph which is not having by the sigmoid curve and other graph is having the sigmoid curve. So I am just taking this graph over here to tell what is the value and how we can represent the information. When we have the any values that lies between 0 and 1, so when we have the values 1, or we are assuming this is our threshold values, we are assuming this is our threshold value 0.5. So when we have the values more than 0.5 or 0.5, so all the data will be plotted on our point, or there will be those data will be considered into the category 1. So all the data is depicted over here. Just tell me right now, is it true? Say yes or no.
Yes, sir.
And all data which are not having the values y, when we are getting the y equal to value less than the 0.5, so we will consider such data into the 0 category. So we are affecting all the data point position over here. So as diagram is this as sigmoid curve is coming from this point. If you're connecting these two data points or these two state points, plotting like this one, like this way, so it is treated, or it is seems to us we are plotting the sigmoid curve. So this curve is known as the sigmoid curve because this is depicted by the with the help of the our important point, and that is known as the sigmoid curve. This is known as the sigmoid curve. So I can write over here sigmoid curve. Sigmoid is basically most important function in the neural network as well as the logic regression to determine the values that lies between 0 and 1. This is the key statement you have to keep in mind. So I'm speaking once again. Sigmoid function is a most important function in the neural network in the logistic regression that determines the values that lies between 0 and 1 only. So this is done by the sigmoid function. So this curve is known as sigmoid curve, and this is the curve inside the logistic regression. Now this is clear to right now, and now the output to the actual known proper depicted diagram we have on the right side. Left side I have taken as our basic, so how it will be depicted and how it is represented. So now this is clear to all right now. The basic introduction of the logistic regression and sigmoid function is clear to all right now. Yes, tell me.
So,
Yes, sir.
Okay. So many times I've explained this topic with other students. So this is just the plotting over here. So, and this the values. This gives a y value y that is extremely close to the 0 if x is large negative value, and it is close to 1 if x is large positive value. So after the input value has been squeezed toward the 0 and 1, and the input can be run through the typical linear function, but the input can now be put into the distinct category. That is the term. So that's why we have studied the relationship between the linear regression and logistic regression we have due to this point. And this is another example of the sigmoid function I'm taking over here. So in this case, you can see I have already just I'm highlighting. This is the point. This is the equations of by which we need to get the outcomes or the value of the our neurons value, and it will contain by the some weight and input value following by the bias. So that's why I have written over here n, and n means the neural network. So at the time of the neural network, we will depict all the information. And what is the formula? Sigmoid function sigma z equal to 1 upon 1 plus e to the power minus z, and this is the z which contain the input values. And how we are getting this input value? So this is our formula, z equal to summation of the wi into xi plus bias, and this wi and xi are the input and weight of our neurons. So that part we will see in the neural network, but today you have to keep in mind. So this is another example I have taken over here. and the left and the right side diagram is saying to us when we are getting the value which is more than the threshold value, so we are considering to the 1. If we are getting the value which is less than the threshold value, so we are getting the value 0, or we have categorized the value, we can say. So this is just our example of the Sigmoid function which is used to categorize the data. Let us take an example. It is very interesting example and which is simple example. So let's take them like cats and dogs. So I'm categorizing the cat into the one class and 0 values I'm giving to the cat. So we basically decide them threshold value should be decide the our this input belong to the cat class or this input belong to the dog class. So what I'm taking over here, just read this statement which is to be highlighted me over here. I'm highlighting once again over here. Suppose we have chosen the threshold value that is a 0.5. So if the prediction function return the value 0.7 and this prediction function return the 0.7 value, it means this value is coming through the by. So I can write over here, this is value which is coming. This is a value and this value is of the by. Okay, this is our target value we are getting. So if we are getting the threshold value that is the 0.3, we are deciding threshold value 0.7 and we are getting the y value that is 0.7. So according to this point, we can easily say 0.7 is greater than the our threshold value that is 0.5. So we will consider this belong to the our class 1 because it is bigger than the threshold value that is 0.5. So we will consider this category or this value into the one class. So by which we can easily say now our observation is saying to us the input we are taking that will be considered into the dog class. Now this is a simple example. If we are getting the values 0.2, so 0.2 is lesser than the 0.5. So we can say this y we are getting 0.5, that is the target value we are getting. So from this point we can say this is the lesser than 0.5, so this will be considered into the 0 category or 0 class. So now the particular input what we are taking that is belong to the our cat class. Now this is clear to all right now.
Yes, sir.
And now how we are getting these values? Yes, here what we have decided threshold value and we are putting the some input. So 0.7, 0.2 is just input values. Or whatever we are giving, so inputs based on the input we are getting the y values or the we can say the target value or our dependent variables information. So after understanding this simple example, we have to understand the other parts. But here I am speaking over here in general way. This is the kind of the example may ask you to examination. Just put the values and determine the which is the x value. We have to put the values and calculate the values. What is the y we are getting? So you can consider such data into the respective class in simple way. Just put the values and calculate and see the class only. Any doubt in this example you have? Just tell me right now. Any doubt in this example?
No, sir.
Everything is written in the slide and it is very clear, but you have any doubt, so you can. Okay. If you don't have, so I can move to the type of the logistic regression. Student asked me, sir, what are the logistic regression types? So before starting the class and during the class time, in today's lecture, I've already spoken many times. Two categories we have, yes or no, 0, 1, and true, false. So we can say this would be considered to the binary class. But three or more category we can consider nominal, just like example of the three type of the student branches: cybersecurity, AIML, and core CS. So that is enter coming to the nominal. We can take another example. Multinomial logistic regression, we can say cat, dog, and elephant. So when we have the flocks of the birds, or we can see the group of the or different group of the animals. So from the different group of the animals, we have to find which animal belongs to the which class. So we are finding the three class or more than three class, then we can consider that is enter coming to the multinomial logistic regression. So in the exam time, you have to understand what kind of the logistic regression we are following. And next one we have the ordinal. So ordinal example, you can understand I'm categorize the student based on the year. Okay, based on the year, first year, second year, third year. So this is the our multinomial. But if I'm defining the student status based on their grade. So from the my 60 student, I'm observing some student got the first grade, some student got the AS, second AS grade, B grade, and A grade, and C grade, and so on. So if I've categorized the student based on their grade, that is a rating we can say. So this is the ordinal. What is the order I am following? As student grade will come in a simple group, and this A plus grade student will come into that group. So what I'm using, I'm applying the order. So based on this order, if I'm doing some logic regression work, that is enter come into the logic regression. But practically, but numerically, we will always support the binary logic regression only. We will not touch the multinomial and ordinal logic regression. But these are the two different type of the logic regression we have to keep in mind properly, other than the binary logic regression. Binary logic regression, multinomial and ordinal logic regression, we have to keep in mind properly. So, but truly speaking, when we do any numerical portion, when we work on the practical parts of binary logic regression, we will convert. That is the point of view. So this is our introduction of the logic regression. So far we have seen what is the logic regression, what is the sigmoid function, and why sigmoid function is required, and that is more important point. So tell me right now, any doubt so far you have? So please you can ask me right now.
So can you explain multinomial logistic regression?